Hello everyone. So today we are going to work on how to avoid rain particles inside these shelters. So just simply killing particles on collision will not be enough here. It's not just that, because when we use GPU particles, if in order to detect collisions, we would need to see the object that would be blocking the particle. But here, if I am looking at like this, now you see there is no rain inside this shelter, regardless of I am seeing the roof of this shelter or not. Now if I go to the other object also, other shelter also, there also it will be updated, and I will no longer have any, see, no rain inside here, but outside it's raining. So we are using a dynamic kill volume for the GPU particle for these rain particles, and yeah, this is what we are going to work on today. And that outline is to show that the dynamic kill volume of the rain. So yeah, this is what we are going to work on today: how to avoid raining inside indoors or shelters. It's stopped raining now, and it's clearing out. All right. Okay. So yeah, before we get started, let me remind you that you can download the project files of this project and all other thousands of projects I have done in my channel from the Patreon page. Once you become a member, you will be able to access everything without any limit. So feel free to check it out. And here is the full playlist where I worked on this project, Unreal Engine 5 Open World series. So there are a lot of things, everything is explained from scratch. Feel free to check it out if you are interested. Alright, now let's get back to today's tutorial. Alright, so this is what's happening as of now. Let me speed up a little bit so you can see the rain quickly. Right, now here, if I go inside the building, you can see still there is rain inside this shelter. So it's not blocking. So, but you can see some of them are blocked. That's because I have used a CPU particle with the lower density to get these splashes on the ground, but the GPU particle also has collisions. Still, that collision blocking only works if I see the blocking object. That means if I am like this, let me demonstrate this easily by placing directly the rain particle itself. Yeah. Let me place it like this, and now as you can see, now you can see rain particles are coming through the roof. But if I look up, now they are blocked. These things that I see are actually coming from the area of the roof that currently not rendered. So if I see the whole roof of the shelter, none of the particles are going through. But if I am not seeing the roof of the shelter, all of the particles are coming through. That's because GPU particles, in order to work the collision module of the GPU particles, we need to see the object that's supposed to block the particle. But here, when I'm looking like this, I don't see the blocking object, so particles are coming through. Now let me show the particle itself. So here, this is CPU particles. Let me disable the GPU particle for now, so you can see with the lower density. This is only the CPU particles. So here, even if I'm not looking at the roof, even if the roof is not in the viewport, you can see these particles are not coming through. That's because that's how CPU particles are working. Their collision system is different. So we don't need to see the blocking object to see that. But once I enable the GPU particle here, now you see, if I'm not seeing the roof, the particles are coming through. But if I see the roof, particles are blocked. Alright, so we need a solution for this. A dynamic solution that would work even when there are multiple shelter objects. So here, let's go to this rain strict GPU particle, and here I already have this kill particles module when it's collided, but as I explained now, it's not practical. We need to see the blocking object. So there is another kill particles in volume option. So here I change this to a box, and we can set the box size. So here, let me make this like 500, 500, and maybe 1000. And now you see, let me disable the CPU particle, so we only have the GPU particle. Now you see in the middle, there is a hole that we don't have rain particles. So it's here, see? This area. See, this area we don't have rain particles. That's because they are killed by this block volume that I just set. So we can if we have placed the particle manually, we could set this location, but we need to make it dynamic though. So here, let me select this object now and go to right view, because I need to see how large this is. It's 370. Okay, let me just assume it's, let's say 500, 500, 500. This is the scale. And here I'll set this to read from a user variable. So read from a new user parameter, volume origin. I'll rename this kill box origin, and by default it's 0, 0, 0. Let me go back here and now let me remove this. So the location of this is this. Let me copy that. Can I paste it here? I can. Great. So now if I play the game, speed up, see, I don't have, it's hard to test with this character. Let me shorten the spring arm component. Like 400. Right, what happened? Okay, let's speed up. I'm not getting the rain. No. I'm getting it. I just had to recompile. So now here, see, we don't get any rain inside here. Even though, it's not, yeah. it's working actually. So even though, wait, what's happening? I don't think it's accurate. Actually, it is working. I just had to increase the bounds here in this blocking volume. I had to increase this to 1000. So then only it was large enough to show the blocking volume here. Now it actually does work. I don't see rain inside here. So this is just the GPU particle. See here now, if I go inside, I don't see any raindrops in here, but outside I do have. Okay, now if I enable this one also, this should work pretty good, but this is not dynamic yet, and we will look into that. So hold on, let me enable the rain again. Yeah, so now it looks good. I don't get any rain inside, but still, see, there's no raindrops inside the building, but I have plenty of raindrops outside, which is exactly what I wanted. So yeah, how do we make this dynamic? Now that's the next thing. So for that, here, I'll change this box size also to a user parameter, and I'll rename that here box size. Okay, so now we need to dynamically set this. So we have this rain thunder blueprint. Here I'll add a function update rain kill volume parameter. Just learn kill volume, that should be enough. And then get the NS rain, set variable vector 3. I need to update both box origin need to copy the name box origin and box size. Right. Okay. And then this origin and this one size. Now let's open this shelter blueprint. And here let's add maybe a box collision. So here the size is, when the scale of the box is 1, I need to see the size. Here it's 60. Okay, remember that, we would need it. Now here I'll scale it to cover the entire area. This right, and then I'll set this to overlap only point. Now in my character, let me use this on component begin overlap, and on the other actor we need to check if the overlapping actor is the player. So is player, but know that this is not something that you would have by default. This is something that I have already implemented. It's just an interface event, this one. See, if it is player controlled and locally controlled, this returns true. So this would work in a multiplayer game as well. So if this is true, then I'll have to update the rain killbox parameters. So for that we would need a reference to this rain thunder. Get actor of class. I'll use this because this would not be something that happens in every frame also, so it's okay to use this get actor of class. But know that this should make a hard reference to this class within the shutter. Depending on your situation, that may not that would increase the coupling between different modules in your game, but let's just not worry about that for now. Here, update rain kill volume. Now the origin is this box. I'll call this, should I call this particle kill volume get word location. That's the origin. And the size, get word scale. And you know, if you remember that we know when it is the scale is 1, the number of units, the size of this box was 60. So I'm gonna update it with 60. Box default size is 60. Just in case I wonder later on from where did this 60 came from. Alright, now here I'll remove these. Actually, leaving them would be fine. That would work for this map only. But here, if I have another building, speed up. Okay. Now we already don't get any rain here because this is already updated. No rain inside. But if I move to the other building, once we enter that will be updated. See, no more rain inside the building. Is it working? Doesn't look like it's working. I added a debug box here so that we can see when it is updated, if the box is being updated correctly. So it looks like it is, and it's larger than I thought actually. So if I speed up, so it looks like there is a difference between how extents are considered here. Actually now it's working correctly, so I'm not sure what went wrong in the first time. So what I did was I directly go here and double check if these names are correct, copied them and pasted them here and recompiled. And also this extent, I have to, when I pass it as the size, when I draw the debug box, I have to divide it by 2 because extent means like half of the full size of the box. And also we can more accurately calculate it here instead of manually checking the size from here. I can get extent get box extent, And since we need to pass the size, we will have to multiply this by 2 because it's different in the Niagara simulation. We don't need to pass the extent, we need to pass the size itself. So here by 2, well, we can multiply. Well, actually, we could do that in the same note. Okay, now when I do that here, I don't need to divide. I can directly use the size. Oh wait, no, I still need to divide because it's different. Okay, now let's test again. Speed up. Yeah, it started raining. Box updated. No more rain inside the shelter. Nice. Let's go to the other one. Yeah, works fine. No more rain inside this shelter too. Regardless of we are looking at the roof or not. And yeah, that's all I want to cover in this episode. So thanks for watching. As always, updated project files will be available for download here in the Patreon page. Link would be in the description below. And let me know if you have any questions in the comments. See you in another episode. Goodbye.